Okay, let's get started. My name is Cesar de la Torre. Cesar de la Torre in Spanish. I work for the .NET team, most of all in areas related to .NET Core, microservices, Docker, containers, right, and architecture guidance. So today we're going to be talking about these topics. I wanted to know how many of you have been working with a microservice architecture? A few of them. And what about Docker? You've been working with Docker containers? Less? Okay. So, and then, yeah, you're in the right place. So, and then Glenn is also around here, right there. So, and he's going to be helping me from there, you know, like thinking very hard. Okay, so let's start. First of all, I want to highlight that everything I'm going to be kind of compressing here in less than 20 minutes. We've written a guidance about that. It's a whole book, like more than 250 pages about microservice architecture and ASP .NET Core and Docker containers. You can download it from that URL. It's been in preview preview draft for a few weeks, even a couple of months. And now for build, it's like first release. It might evolve a little bit, maybe some code, but it's kind of initially a final version. And then related to that ebook that you can download the PDF, we created a reference application or sample application using ASP .NET Core microservices and Docker containers. So anything we are explaining in that ebook is referenced to that sample application, right? So we're going to be talking about this as well. I also want to highlight that this GitHub application, it's been like during the last month, even when it is in beta, it's been like the second most trending GitHub site in C# for the last month across anything. It's not just about sites from Microsoft, but any C# site, right? So, okay, so let's start. Just very basic concepts about microservice architecture. When you're comparing that with a traditional approach, where you create an application, you might have a few modules or subsystems or layers, and then you deploy the whole application in order to scale out in multiple servers, right? But this is a coarse-grained approach. If you want to scale out something, you need to scale out the whole application. And on the other hand, when you are working with microservices, you create slices of the application, kind of partitions of the application from a business perspective, and then you deploy those microservices in a cluster, and you can create many instances of those modules, and you deploy those modules or microservices independently. Okay, so the benefit is that you can scale out just this subsystem a lot more than this other subsystem, and maybe this one as well. So you have a lot more control on how you are scaling out your application than in a traditional application. Okay, but then you will have many other challenges as well that you need to be aware. The next important thing about microservices is, working this? Yeah, is related to the data. Because the fact that you might be using services doesn't make you a microservice-based application. You also need to be able to deploy autonomously your microservice, and that means its related data. So each microservice has to own its data, so you can change anything in that microservice on anything in your domain model for that microservice. Could be a different development team than the other development team for the other microservice, and you can deploy the whole thing autonomously. That's the most important thing in microservices, right? So compare that to the traditional approach when you might have many even services like service orientation, but then if you have a monolithic database, then it's not a microservice orientation, right? Because then anything you do in that database is going to impact many other services. So that's the main difference. Of course, the first question here is, okay, but how do I identify those domain models per subsystem? And sometimes the same entity might be in different subsystems. And so that's kind of the discussion you can read in the ebook because it's kind of more time, requires more time for that discussion, but you need to identify those bounding contexts for each business microservice. And sometimes you have the same entity in multiple microservices, but maybe in one you have more attributes, in the other one just have maybe the ID and just a couple of attributes. It's like you have to identify that different models between them. Okay. So basically, a very basic recap about microservice and ASP.NET Core. In ASP.NET Core, you usually will be using ASP.NET Core Web API services, using HTTP, at least for the initial communication between the client applications and the microservices. That's the common approach. Then you can use also asynchronous communication using messaging, any broker of messages between the internal microservices. With ASP.NET Core, you have unified controllers between MVC and Web API, dependency injection out of the box, middleware, so you can put your own aspects or execution in the execution pipeline of the web service. And also something important in microservices is that when you're deploying a microservice application in the cloud, you have to embrace the fact that eventually you will get failures, partial failures or outages, but you have to embrace that fact. So sometimes maybe a database is going to be moving from one node to the other in SQL database, or maybe maybe the connectivity is going to be dropped for a few seconds or just 1 second, or like partial failure is going to be pretty common in the cloud. So because of that, you need to implement techniques so you have resilient applications. So usually you might want to use HTTP calls with retries and exponential backoff. So, hey, I'm trying to consume this microservice. It's not working right now, but maybe in the next second it's going to be working. I mean, maybe it happens in a while or maybe next day, but it will happen, right? So in that moment, you can do several retries with exponential backoff. So each time is going to be a little bit more time. And also circuit breakers. So if a lot of microservices are doing that reply, eventually you need to say, hey, this is an error because it's not gonna work, and you need to raise an error, because other than that, you could be generating a denial of service by your own, right? And finally, the best way to avoid these kind of issues is try to minimize synchronous HTTP communication between your microservices. So, of course, from the client application to the microservices, you will be using HTTP, but between the microservices, try to minimize HTTP communication, try to use messaging, maybe propagating information with events and messages. That's the best way to have like resilient microservices, okay? So now about Docker, sorry. And very quick, to summarize Docker. Docker is about dependencies. So think about a Docker container like a process with all the dependencies that process has in regards to frameworks or everything, .NET framework, other libraries, whatever. Anything that you're going to need for that is the container image. So basically, the typical phrase that you may hear from developers, hey, it was working in my machine, why it's not working in production? This doesn't happen in Docker because everything, all the dependencies are in the image that you are deploying. Okay, so that's kind of very quick summary. And then you have .NET on Docker. You can use .NET Core Docker images, which is cross-platform on Linux or Windows Nano Server. Or you can also use .NET Framework, full .NET Framework images, which is on Windows Server Core. And that's important because, of course, you can use full .NET Framework on Windows Server Core for lift and shift scenarios, like a legacy application, a monolithic application that you want to deploy in Docker, and so you have less deployment issues, that's okay, like the other session that we have here about WCF or things like that. But that image, because it's full .NET Framework and Server Core and IaaS, is going to be huge. So that image is not good for microservices. So if you want to do microservices plus Docker, you should go and use .NET Core. That's one of the reasons why you want to use .NET Core, okay? And finally, let's go to a demo. So, yeah. So everything, like all the links that and guidance that I'm going to be talking about, you can go to microsoft.com/nesh/architecture, right? And in here we have, you can download the architecture microservices ebook, the sample application, patterns, a similar thing about plain web applications, sample application and ebook. Also another ebook about Xamarin and mobile applications, but talking about design and architecture and patterns. And then if you click on the application, the reference application, you go to GitHub. The name is eShop on Containers because it's like a simple e-commerce based on microservices and containers. You have here the information. This is the architecture. Okay. Basically, we have a client mobile Xamarin application, Xamarin Forms, a traditional MVC HTML application, a single page application using Angular and TypeScript. And then we have a few microservices types, identity with OAuth and ASP.NET identity, then a catalog microservice, ordering, basket. Those have databases deployed into a single container with a SQL server in a container on Linux. And that is great for a development environment and testing, because you can do tests, integration tests, and so on. In production, of course, you would move those databases to Cluster or Azure SQL DB, right? And then we are using an event bus. Underneath it is using RabbitMQ in another container. You could swap that and use Azure Service Fabric or any other service bus, and service bus or mass transit, right? But for a development environment, you just grab the code. You just need Docker for Windows, and everything will work in a single development machine, okay? So let's go to the code. Let's see here. If you see the solution. So this is a web API for the basket, web API for the catalog, the identity API. This one is interesting. What we're doing here in the identity web API is internally we are using ASP.NET identity, and then so the users are in a SQL database, and you authenticate in a similar way that you can use ASP.NET identity in MVC. But when you do it in MVC, it is kind of coupled, right? So what we're doing is we wrapped ASP.NET identity in this web API microservice, and we are using Identity Server 4, which is an open source, and then we are providing OAuth tokens to the client applications. So we use the same authentication token for the Xamarin application or for the single page application or for the MVC application, right? And then the ordering API, this one also is using SQL, but the basket and the catalog are very simple. If you want to just see a container and something easy like CRUD, create, read, update, you can research that code in the catalog API. Then the ordering is more complex. It's whenever you have a lot more of domain business logic. Then in that one, in the ordering, we are implementing domain-driven design patterns and aggregates and all different domain-driven design patterns implementation in .NET Core, okay? So that's kind of a quick summary of the solution. Something important would be in regards Docker. So in this solution, we have, first of all, in any of those microservices, this is like a typical API, web API, but the difference is that you have this Docker file, right? It's open here, and this is how you define how your web API is going to be built with a Docker image. So it's going to be using this Docker image, base Docker image, ASP .NET Core, then what port we are exposing, and what's the entry point of the process, which is the catalog DLL, right? And then, so therefore, you have one Docker file per microservice to create the image for that microservice. And the next thing is, with Docker, you can compose an application. You can have like a multi-container application, and you can define that with this beautiful file, which is called Docker Compose here, right? And this is the standard format used by Docker, which is open here on the left. So here you can define all those services, like the basket API, what image I'm going to be creating, what Docker file is using in order to create that image, and then the dependencies on the other microservices, the catalog API, identity API, ordering API, the web spa, and also the SQL container and the RabbitMQ container and all that configuration. Okay. This is kind of the static information for the images. Then you can also have another file, which is the Docker Compose override. And in here, you can define specific information per environment. So you can have environment variables here that are specific to the development environment, or you can create another Docker Compose override .prod for production and so on. So you can kind of decouple what is static and what is depending on each environment. So finally, what I'm going to do now is what is great in Visual Studio and Docker is that you can use Docker just with Docker CLI, the command prompt and just any editor like Visual Studio Code, and you can deploy to Docker. And then you would do that using Docker Compose app and right on the root folder of your solution, and then it will be deployed into the Docker host. When you install Docker in Windows 10, you have here Docker for Windows, and when you install it in Windows, then you will get a Linux VM in Hyper-V, right? This one, mobile Linux VM, and this Linux VM is where your containers are going to be deployed when you do a Docker Compose app. But if you do it instead of directly with Docker Compose app, you do it from Visual Studio, which under the covers is using Docker Compose app, then you can debug those containers and even multi-containers. So I'm deploying, let's do it right now. Just you need to have these the files as a startup project, and then once you do that, you can just hit F5, and it's going to be deployed into the Docker host in the Linux VM. Just as easy as that. It's going to take a few seconds. Something interesting here is that because we are loading different containers, because we have like 7, 8 containers, maybe the web API is trying to reach a SQL container, maybe it's still not ready. So that's one case where we are using that resiliency that I mentioned. So we are doing retries. And hey, the SQL container is not ready, but then after a while it will be ready. So once everything is ready, because of those retries, then it will pop up, like the solution from Visual Studio and kind of the default application, as you see now. And here is the application, right? And what I'm going to do now is, we could see many more things about the authentication and so on, but I'm going to show you how to debug. So I'm going to enable the breakpoints. Basically, what I have here is not this one, catalog controller, and not this one. OK. So on the left, you can see a controller from the web MVC application. Okay, so that's the web app. And on the right, you can see the catalog API. So this is a web API in a different container running in the Docker host, right? So what I'm going to do is just refresh the application. So it's going to the web MVC. This is a breakpoint, and you can see that here is going to call to the catalog service. I press continue again, and then we jump to a different container, debugging now the catalog API, which is using maybe in this case Entity Framework Core and querying the database, and then continue, and here we are in the application. So that's pretty super convenient because you can see everything. If you do it with the command line, I mean you'll need to debug just with trace files. That's the only way to do it, right? Right. Let's go back here. Oh, sorry, in the other one. There are many more things that I could show you in the solution. If you read the ebook, and every chapter is pointing to the application about communications, resilient, and then even within the domain-driven design about domain events, integration events with messaging, many more things, okay? So something important is, okay, but that environment with a single Docker host is great for development, but then when you are going to production, you need to scale out, because in a single Docker host, you have one instance of container, and that's it. If you want to scale out and have many instances per container or per image, then you need to deploy it to a cluster. I don't know what's going on with the colors, but well, in this case, you would have like a cluster of hosts. Could be Linux hosts, or could be Windows for Windows containers. The thing is that you have like the base images in Docker with .NET and Windows containers, or .NET and Windows, or other languages. Then on the other hand, you have the web APIs that you are creating with .NET Core, and you build the images. If you use Visual Studio, that's going to be done under the covers. If you use the command line, you will build the images with Docker build. And once you have the images, you can push it to a registry. It's not in the picture. Docker registry, so like Docker Hub or Azure Container Registry. And from there, you deploy that into the cluster, right? And you could have many instances of those images and scale out the way you want, right? So that's you have high scalability, a lot of density per host, because you're going to be able to have many containers in there, right? So about that, in Azure, kind of you have the regular VMs. You have on the other extreme app service and Azure functions, like more PaaS. And this is more like not for complex microservice applications, more for regular web applications or microservices, but isolated or not a very complex solution. And then for that, you have orchestrators, either Azure Service Fabric that can also use containers, or you also have ACS or Azure Container Service, which is the infrastructure to use either Docker Swarm orchestrator or Kubernetes orchestrator or Mesos orchestrator, right? So in this level, it's the right level for microservices, but also you have a lot of control. You can see what's going on every VM, etc. Like things that are like a black box in app service. In here, you have all the control. Okay. So here's a table, a summary, like choosing orchestrators in Azure, Service Fabric, Docker Swarm, Kubernetes, and Mesosphere, DCOS. Basically, Service Fabric is a lot more mature in Windows, and you can also use microservices with no containers, like plain vanilla processes on Windows, and many mission critical products in Microsoft are based on Service Fabric. For instance, SQLDB in Azure, or Service Bus in Azure, or the backend of Cortana, or the backend of Skype. All those products are based on Service Fabric. But for instance, in regards containers, it's still in preview state with Docker containers. And then if you are more in a Linux environment, then Docker Swarm, Kubernetes, or DCOS are more mature in Linux, less mature in Windows. That's kind of one way to think about it. But then, of course, you need to see all the different characteristics of all the orchestrators. Docker Swarm is very easy to get started because you can just deploy it using the same Docker compose file that you saw, and you deploy it to the multiple instances of services. Kubernetes is kind of in the middle between DCOS, which is more complex, but all of them are ready for production. Okay, and that's it. Like key takeaways. Microservices offer great benefits, especially for long-term applications that are evolving, different subsystems, kind of large applications that maybe with multiple development teams working on it. But also, you will get many new challenges with distributed computing, right? So that you have to take that into account. So I wouldn't use microservices for anything. The microservice architecture is for those large, scalable, and evolving applications. However, Docker is a great fit for microservices, but you can also use Docker with a monolithic application or regular web application. Just put it in a container, and then with all the dependencies, and you will solve many deployment issues, okay? So Docker is an enabler for containers, for microservices, but you can also use it with regular applications. and from our point of view, containers, Docker containers are going to be ubiquitous soon, now, and every vendor is kind of supporting Docker containers, not just Microsoft, but Amazon, IBM, Google. So it's from my point of view, in the medium term, it's going to be kind of even like TCP/IP, right? So that's all. Remember, you can get all the information about the guidance and the book and the application here. There are many more things that I don't have time to talk about it, like domain-driven design, aggregates, CQRS simplified, domain events, integration events, and so on. You can see that in the ebook. You can also go to .NET/architecture and see all the links. And that's it. We have a couple of minutes for questions. This is Glenn. Where are you? Yeah. So any question? Yeah. Thank you.